I got some good feedback about doing the ACT passage like this, so we're going to see interpolation and extending your line on this ACT passage, which is this graph. Okay, so let's work them. According to table 1, the distance from the power plant as it increased, the pH level increased, decreased, increased and decreased, then cannot be determined. Okay, so table 1 is right here. So our water source is going in this direction. We've got our distance going in this direction. Our pH is going in this direction. So as we increase the distance from the power plant, our pH goes in the same direction. So as we increase, we increase. Great. Figure 1, the number of days increased. As it increased, the radiation level, does it increase, decrease, increase for some, decrease for others, increase for some, and decrease for others? Okay, looks like there's a typo there, but that's interesting. So figure 1. So now we're not looking at table 1. So number of days, that is, guess what? That is our label. Okay, we just learned that word over here. Of course, we already knew it, but okay, so it's the labels. Okay, there's boxes on this figure. Okay, so days. So as the number of days increased, the radiation level, did it increase? Okay, so it is increasing. So it is going up. Okay. And we have to look at each water source. So all 3 water sources are each one of these lines. So we would say it increased. Okay, according to the data, as the pH level increased, the radiant, okay, so the data means any table or chart, right? Because it doesn't specify study 1 or study 2. So according to the data, as the pH level increased, the radiation level did it increase or decrease, or no trend, or constant? Okay, so now we're looking at this. So we've got to look at our locators. So pH is our what, and then another what would be radiation. So pH and radiation. Okay, are they on the same one or on different ones? Because there's not radiation here, but there's pH, and there's no pH here, but there's radiation, right? So we're going to actually look at both of them and compare. So as we have pH increase, what changes that's common with this? So pH and distance. Is distance on this table? No. pH and water source. Is water source on this table, on this figure? Well, there's no water source over here, but the water sources are right here. Okay, so we've got water source 1, 2, and 3. So we could actually draw our trend arrow on this little key. Okay, that's another important part to charts. So now we can actually compare these two, right? So now I've got my pH increasing from 1 to 3, and my pH is increasing, but so we could even draw this like this, pH. That's the way it increases right there. But now we've got radiation going in the opposite direction. So this is the direction that radiation increases, but pH is increasing in this direction. So that means that if pH is increasing this way, that means radiation is decreasing. Okay, decreased only. Okay, we could actually draw this like this for each one. Oh, see, look. Okay, let's look. Let's double check. I think I think I made a mistake. So the direction that you draw these matters. So I think I made a mistake here, right? So we've got to draw from this outward. Okay. Why? Because this shape, if you can see it, this shape is a circle, and on our chart, the very bottom line is a circle. And so we're going to be radiating from the circle toward the box, okay? From the circle toward the box. So really we should be drawing it this way. So as we go over here, we've got pH increasing while radiation's increasing. Okay, if you saw what I drew, pH is increasing, radiation's increasing. Okay, so we would not draw decreased, we would do increased. There, you saw me make a mistake. According to the data, as the distance from the power plant increased, so as distance increases, the radiation level does what? So does the radiation level increase, decrease, increase, then decrease, or remain constant? So distance. As the distance, and we remember how we're relating this table through the water source, okay? So distance is going in the same direction as pH, right? So distance, okay? So as distance goes. All right, so distance is going in this direction, so it must have the same relationship that radiation had. So radiation and pH were both increasing at the same time. So distance is increasing in the same direction, so it's just increasing. Suppose that a study was allowed to take place an additional 5 days, for another 5 days. Based on the results of the study, 2, the radiation level, so this is where radiation for water level source 2 would have been what? So what we're looking for is water source 2. Where is study 2? Okay. And what we're looking for is after 5 days. Okay, so after 5 days, 5 more days, plus 5 more days. Okay, so if we look at our figure, this is study 2, figure 1. They're asking us to add 5 more days on here. Okay, so remember when we extended our line, because we didn't have something, right? We didn't have this 0.3 day, this extra 0.1 days over here. We added 0.1 days. Right here, we're going to add 5 days right here. And we're going to go over to 25. Okay. And now we're going to extend our line. Do we need to extend all the lines? No. We just need to extend the one they're asking us for, right? So there you go. Okay. We could extend that one. That's water source 2. So water source 2 would have most likely had a radiation level. Ooh, yikes, I drew through that. Radiation level of, it's going to be, here's 1,000. We know 1,000 gets hit for sure. So let's go ahead and eliminate. So it's not going to be this. It's definitely not going to be this because there's not 1,000 in there. Those aren't going to be there. And, well, I guess it'd have to be greater than that. So we'll choose D. Right? So a lot of the times they don't even ask you to draw this Y extra increment, right? So this would be 1,100, but they didn't even ask you for that, right? Which is probably where it's at. Okay, but they didn't even ask you. They just gave you 950 down here. Okay. All right, so 26. Suppose an additional water source was discovered at a distance of 27 meters from the power plant. Okay, they're asking you to do some. This is not interpolation. This is not interpolation with a line, but this is with this is with a table. Well, actually, let me take that back. Sorry. So 27 meters, they're going to ask you with the line and with the table to interpolate, okay? So we've got the distance right here and the radiation level, okay? So let's look at where our locators are pointing us to. The distance, the word for distance is pointing us to table 1. But the word radiation level is pointing us to figure 1, okay? So now, if study 2 was repeated for a distance of 27 meters, what would the radiation level be? Okay, so they're asking us basically to make a new water source. Water source at 27 meters, okay? And so they're telling us to put our distance somewhere in between here on the table, okay? So we're going to be in between 2 and 3. And so this is important. This is very important. Sometimes, instead of telling you to draw a new extension on the line, they're going to tell you to draw a new line, okay? A whole new line. So you see how I drew this line in between here? The way I found this was they said that I had a distance for my water source at 27 meters, okay? Water source and distance are right here. 27 meters is in between 25 and 30. So I drew a new line right here because I know that they're trying to get me to relate water source and distance, right? And so this is the only place where it's related. And then they're trying to tell me, where am I going to find that radiation per day? Okay, so when we draw this line here, we're going to relate that by just approximating in between water source 2 and 3. So here's the key for water source 2 and water source 3. So in between the box and the bow tie. So in between the box and the bow tie, I'm going to draw my water source, new water source line. Okay. So on day 10, that's where they want me to do. So I'm drawing my dotted red line up to that. And this is where it would be at. So it'd be somewhere in between 600 and 700, maybe at 650. Okay, so it would definitely not be less than 550 if we go back to the problem. 550 and 600. Well, definitely not under 600. So G's out. Between 600 and 650. Maybe. Okay. 600 and 650 is a good guess. And then greater than 650. Okay. So if we look at this other box is about halfway in between, right? The box one. So this is probably a little less than 650. Okay, so we're not going to say that one. We'll say H. Okay. All right, so what we learned from this, they can ask us to add more data here, and they can also ask us to add more data in between the lines. So right here. Right? Okay. So that's what's really important about this passage.